Hey guys, welcome back. So today, we're working on this Briggs and Stratton standby generator. And standby might be the wrong word to describe it because it doesn't have a connection for a hard line, at least as far as the propane goes. Instead, it has a setup to connect to two, like grill-sized propane tanks. The other giveaway is that there is no place on this machine to hardwire it to your house. Instead, we have some outlets, much like you'd see in a portable. And we also have a momentary switch right there. So you have to start this machine manually. It doesn't look like it starts automatically when the power goes out. The other thing of interest is that it's a bonded neutral, which usually you would not see on a standby, rather a portable machine. Anyway, this one I know absolutely nothing about. My friend Jason actually picked it up from someone who was selling another machine. Jason happened to look over. He saw this in an overgrown garden and asked about it. And the owner of the house actually knew nothing about it. He had moved in, and the prior owner left this one behind. So I think it's been some time since it ran. Whether it still runs, I am not sure. But I'm told it was quite a mess, actually, when Jason pulled it out of there. He ended up washing it down. He said he pulled the cover off and found a bunch of mulch and wood chips inside about a foot deep. So yeah, does it still run and make power? I'm not sure, but we're going to find out. So let me set up a little bit better and get going on this. And things don't look too bad in here. Actually, it looks like he cleaned it out pretty well. And it's also interesting to see here this seal. I worked on a similar model a few years ago, and the diagram showed a full seal going to the top, and we only had half a seal. And it looks like the same is true here. So I would say the factory intended it to be a half seal. I'm also noticing we have a bunch of pine needles in here. So I'm thinking, there could be a nest on the head, and we probably need to check that before trying to turn this thing over. Although the engine doesn't seem to rotate, at least not with one hand, so that is a bad sign. We also have the air filter right here, which does look like it has some debris in it. But it kept it out from going into the engine, so that is a good sign. Anyway, let's check the oil real quick, and even maybe before that, let's try two hands to get this engine to rotate. But if it's locked up, we're not going to get very far. And no, we're not getting any movement from the engine. So yeah, I don't know if it ran out of oil. Maybe it's not the engine that's locked up. Maybe it's something on the generator side. But the fact that I see pine needles in there gives me a little bit of hope that potentially it's a critter nest. The oil actually looks clean and filled to the right level. So that gives me a bit of hope that the engine isn't bad. So let's continue here. Let's get this blower housing off. If we're really lucky, there's just a bit of rust on the flywheel, and potentially, rust might be holding this up, or a critter nest. Either way, we can get better leverage on that flywheel. Let's see if we can get it to spin. Yeah, it looks like the cover is slotted as well, so we don't actually have to remove these bolts all the way. So just two on the front, I think two on the back, and this should lift off the engine. And I may have spoken a little too soon as well. It looks like the airbox is part of this, so we might have to disconnect that as well. And although technically we don't have to remove these, it is going to be a little bit easier. Pretty sure the airbox is connected just with like an O-ring connection, so we might need to, wiggle this cover a little bit and twist it to get it released from that O-ring connection to the intake pipe. Yeah, I can tell there's a lot of stuff under here that doesn't belong. Although not too bad. This debris I saw, this is actually the mulch, or some of the mulch that Jason was talking about that was down lower in the machine. So how it got inside the engine area, I don't know. I was kind of hoping the ignition coil was rusted to the flywheel, and it's hard to tell, but I don't think that's the case. But this stuff is kind of packed underneath the flywheel, so that could hold it up, but it's not moving at all. So let's scrape some of this stuff off. We'll vacuum it out and keep going. See what the issue is. So I'm just going to block off the intake here because I'm going to blow the rest out. Throttle's not stuck, so that's one good thing, I guess. Let's see if there's any improvement here. Nope, nothing moves. So I'm going to try to get the coil off next. I think I see a gap on, I guess, the side closest to you. The other side, potentially is rusted to the flywheel. Although I would have thought, we could have broken it free. But let's just rule that out before digging too much deeper. And I actually do see an acorn down there. So although this didn't look like a rodent nest, I'm thinking it was, there's really no other way this stuff could have gotten in here. I don't think it was the coil. It's moving around. It wasn't actually rusted to the flywheel. So I don't think that's gonna do anything for us. And no, still stuck. So I'm just gonna get this coil completely out of the way. And I'm thinking we should pull the spark plug, see if there's any rust on it. Okay, it broke free and it's actually turning out pretty well. which is a good sign. Usually if there's rust on the plug, it's going to fight you the whole way out. And yeah, plug looks actually in really good shape. So I don't think the issue is with the top end. But just in case, we're going to add some Marvel Mystery Oil and a bit of penetrating oil. And let's see if that did anything for us. And no, not even a little bit. So, yeah, thinking the issue could be down below. But let's see if we can get this protective screen off. I actually want to get like a breaker bar on the flywheel, and we'll just try to move it a little bit, see if we get anything out of it. Okay, it moved. And it actually sounds like under the flywheel is the problem. I hear a lot of scraping, which seems like it's external, kind of in this area. So yeah, let's pull the flywheel off. Or actually, might be able to blow it out. Let's try that first. All right, it actually feels good. It sounds good. Let's see if we have any compression here. Try to get my finger over the hole. Yep, we have compression. I thought for a minute this might end up being a teardown video, and potentially it could still be, but the engine rotates, it sounds good. We have compression, so theoretically this should be capable of running. So I think the next move here is to spin this engine over at speed. It's electric start only, and the wires for the starter go into this panel right here. So to get access to the battery, I think we actually have to remove the front panel. There's only one screw visible externally. So let's remove that and see if we can pull this panel out of the way. Okay, wasn't expecting that, but it looks like the outlets are separate from the front panel, and we have the battery down there. So we'll check the battery real quick before pulling it out, but I would say this machine has been sitting a very long time, and the battery, not going to take a charge. We're at 1 volt, so yeah, battery is done. So let's get this old one out and get a good one in its place. Yeah, I was kind of hoping that this battery would be marked, with the date code, but I'm not seeing it, so it's still kind of a mystery, when this thing last ran. just going to clean up these leads a bit, make sure we get a good connection to the battery. So hopefully this battery works. It is brand new, but it is dated December 2024. I think when I bought it, it was already 5 months old, and obviously it's been sitting on the shelf here for a while. So it's already, well, about 1.5 years old. I think before we connect up the negative on the battery, let's just pull this towel out. Just in case it decides to crank, and I'm also going to pull the system board fuse. We don't want it to crank until we're ready for it. All right, passed the spark test. And let's get the fuse back in, although I'm not going to use the one that came out. It's not blown, but there is some corrosion on the contacts, so we're going to use a new one, although the shape of the terminal is different, so I don't know if that's going to be an issue. Probably not. So let's try to crank the engine. All right, so I'm going to hit the switch, and I'm going to cover this up just in case debris starts flying around. Contact. And we get nothing. Well, we get a click, but the starter's not moving, so potentially the starter's bad. Or maybe the relay's bad. Let's try it again. And no. Starter, it's not engaging. All right, so we're down here again. The battery, I don't think is the issue. I guess we could check the voltage real quick just to make sure. It has been sitting for a while. But the fact that the relay is clicking with such authority tells me likely the battery is not the issue. And yeah, we're at 12.66. So the battery is good. So the question is it the relay that's bad or the starter, or potentially the wiring in between? So you could use a multimeter to test that. I'm just going to use a test light. So one lead here is on battery negative. And if we touch the other end to positive, that light lights up. So this wire comes up to the relay here on the left side. So this should have full-time battery positive, which it does. And if we go to the other side, that is the side that is switched. So right now, we have nothing. But if I hit the start button, let's see if that light comes on. And it doesn't. So the issue actually is the relay. Doesn't mean we don't have starter issues, but the power isn't even being sent to the starter. So this relay, likely the contacts inside are dirty and just not allowing power to flow. So let me see if I have another relay we can swap in there. So I do have another relay. I guess the question is it good? And I think the answer is yes. I have tested this. This came off another machine, and it was a good part. So it was saved. Not new, but better than what's in there. So really the only difference between this relay and the one that's in there is that this is a 4-wire relay. The main lugs are the same. You have power in. When the relay closes, you get power out. And on the low voltage side, the signal side, you have 2 wires here, whereas this one only has 1, which is the positive. The negative on the 3-wire relay is actually picked up through the bracket. And this one doesn't do that. It actually picks it up right from here. So you could just jumper a wire from here to the bracket, and that would pick up ground. You could also run it pretty much anywhere to the frame or right to the battery. But other than that, there's no real difference here. So I'm going to get the battery disconnected again, and then we need to disconnect all these wires, which we do have this propane line in the way. I'm going to leave it there. We're just going to have to work around it. And always disconnect the negative first. And when connecting up the battery, connect the negative last. The thought behind that is that if the wrench touches anything, you're not going to short out because the whole frame is negative. But if you do the positive first and you touch anything, you're going to short the battery out because there's a return path for the current. But once you disconnect the negative, there's no return path. So you can then disconnect the positive and not worry about touching, the frame. Although you do still have to be careful you don't touch that other battery terminal. And we'll just get this out of the way. And it looks like there's actually 2 positive taps going into that. And it's definitely corroded on there pretty good. Yeah, I think we might end up replacing that one. There's a lot of green on it. Other side isn't a lot better, but we do have some extra wire, so I think we should clean that up while we're here. And as far as this connector goes, I don't have this type of eyelet adapter, at least not for this wire gauge. So instead, what I'm going to do is just convert this from a spade to an eyelet, more like something like that. That one's good. And we'll do the same to the other. So we're going to get the good used solenoid installed. I did connect a ground lead on the terminal on the right, and we're just going to bolt it in like that. And the positives will go on the other side. And technically, this can be either way. It doesn't matter which side is positive and which is negative, but since positive was coming in on the left, we're going to keep it that way. So let's get these positive leads on next. And last but not least, we can connect up the wire that runs over to the starter. And then the one that goes to the battery. And we'll do a quick test. And last but not least, we're going to connect up the wire that runs down to the battery, as well as this wire, which goes to the switch to crank the engine. All right, battery's reconnected with a known good solenoid. So let's try this again. Contact. Very nice. And I did put this on the charger. Not that I expect this battery to be any good, but this brand tends to come back. Not great. It only holds a charge for a few weeks, but something that could be useful in testing other machines. Anyway, I'm going to spend a minute, kind of clean up the mess I made, fixing the issue down here. And now that the engine turns over, we can get the coil back on, check for spark. We'll also get the compression tester in there and see where it comes in at. So actually, before we test for spark or compression, I want to see if we have oil pressure. This is a pressurized system, and you can see right on the side of the filter here, we do have a pressure switch with a wire coming out of it. So that wire or that tab should be grounded when there's no oil pressure. So if we hook up a test light and crank the engine, that ground should go away and the light should turn off if we're building pressure. So I'm going to hook up the test light to battery positive. And then the probe end, if it touches any source of ground, that light is going to light up. So when we touch this to the tab there on the pressure switch, it should light up until we build pressure. And the other thing I'm going to do to make this a little bit easier for testing is just hook up this remote start. We need to hook up one lead to the coil on the positive side. That's what needs to be energized to crank the engine. And then we just need power. So we can hook it right down here on battery positive, but we can also get power from this terminal since it's connected right to the battery. And now if we just click the switch, the engine will crank. And there is a lot of corrosion on that tab. So he might actually need to clean it. All right, that's a lot better. You know, with that tab having all that corrosion on it, it would have thought it had oil pressure even if it didn't. So let's crank the engine. That light should turn off if we're building pressure. And yeah, it turns right off. Perfect. And there's also a lot of corrosion here in this spade connector. So, you know, again, if there's a ground and it's not able to pass the ground, then the system's not going to know that there's no oil pressure. So it's important that that ground signal is carried over. So we're going to put on a new end to this wire and then get it reconnected to the pressure switch. Well, I forgot to hit record, but all I did was clean up these posts. You know, all the corrosion's been removed, and did the same to the back side of the coil where it touches. You need to have a good ground connection, you know, between the coil and the block in order to get spark. So I'm going to get, actually, we'll leave the wire off for now. We'll get the coil back in place, and we need to set the gap to about 0.010 of an inch. So I'm going to hold the coil all the way back so we get the largest gap possible between the coil and the flywheel. And we'll snug it up. Not too tight. Those like to strip out. And then we can use a business card, which is about 0.010 of an inch. And what you want to do actually is rotate it so that the magnet is centered. Like that. Put the business card back. And just loosen up these bolts. The magnet should pull it in. You know, hold it there. Snug these back up, remove the card, and you should have the perfect gap. And then just rotate the engine. Make sure there's no contact. And we are good. Yeah, we might have a problem here. Looks like the mouse chewed some of this insulation off. I don't see wire, but you know, that's going to weaken the protection, and the spark could jump out of there instead of on the plug. So let me see if I have another coil that might work with this. So yeah, I did come up with another coil. This one likely came from a storm responder, but it seems to be the same part. And more importantly, there is no damage. So we'll get this one off. And put this one in its place. The only notable difference is that the other one had some protection on this wire to prevent it from rubbing through. And I usually never see that, so I'm not sure how critical it is. It actually would have been nice if they'd run it all the way up So the mouse would have chewed that instead of the actual wire. We're good. All right, let's check for spark. If we have spark, this tester should light up, although it's pretty bright in here, so I'm not sure how well we're going to see it. And we also have the original plug that we pulled from this machine. So I'm going to kill the lights. It's still quite bright, but I'm going to try to put a shadow, at least over the light. And let's crank the engine. Okay, good. We have spark, both at the tip of the plug as well as the light. So spark, not an issue. Let's check the compression. And let's see here what we have for compression. Now this likely has a decompression system. They usually do. So we want to see 60 PSI at least. We might see a little bit higher, but chances are we're not going to see full compression. And that's not bad. About 110 PSI. So that is plenty of compression. This engine should definitely start with that much. So let's get the plug back in. We can connect up the kill wire on the coil, and I think we can get this blower housing back on. And then we can change our focus to fuel. So we do need to do a little bit more cleanup. I can see a leaf in there, an acorn right there. But the more concerning thing is actually the kill wire. I just connected that, followed it kind of under the starter, and then it comes out right over here. It's not actually plugged into anything, and I don't see actually where it would go. So I'm going to look around a little bit, but we are definitely missing a wire here. Yeah, it's interesting that there is absolutely no sign of that wire. Either way, it shouldn't be a big deal to run a new one. Ultimately, that wire should be running over here to the stop switch inside the control panel. So let's open up the control panel and take a look for that missing wire. Worst case, we can always run a new one from the switch over to the coil. That screw is loose, and so is that one. So, yeah, I think we know what happened here. Somebody was in here. Yeah, I do see traces of a nest. At least a critter was definitely in here at some point. This is the switch in question. Not seeing the wire, but I'm actually going to disconnect the 12-volt battery because we do have live power coming up here from the battery. And once that's disconnected, we can pull this out a little bit further without too much worry. Yeah, I do see issues here. And this is the issue. Well, at least something that doesn't seem right. This is a relay. Cover's missing. There's corrosion on it. And I can't see any reason why this would have a relay in it. So I think someone's been in here modifying stuff. You know, to what end? I am not sure. So I'm going to spend a few minutes and kind of backtrack and try to figure out what is going on here. So I was able to find the wiring diagram for this machine, and this has helped shed a little bit of light on things. I guess first off, this diagram makes no reference to anything connected to the ignition system. So this wire floating off in space, I think, is by design. You know, the way this machine shuts down is by actually killing fuel and closing the fuel solenoid, which brings us to the relays. You know, these are what help orchestrate that, and both of these are factory. You know, where the cover went for this one, I am not sure. You know, given the corrosion, likely it's not in good shape. So at a minimum, we have to replace that. You know, I'm also kind of suspicious of what's going on here because there is some electrical tape and some bare wire exposed. So I don't think that butt connector is factory. So I'm just going to take a second, review the diagram, kind of compare this to what I see. And if we find any alterations, we'll set it back to factory before going for the first start. And one really odd thing that, according to the wiring diagram, is correct is that these two neutrals, they are bonded up right here and then connected to the ground on this diode. And then it's jumpered over to the outlets using this questionable wire. Now, this screw is what holds it all together. And that's just into a piece of sheet metal. So, you know, I could definitely see that becoming a problem if this loosens up. You know, so why they designed it that way, I'm not sure. You know, potentially we might relocate that. But for now, I'm just removing this bolt because we need to replace this wire anyway. And this is kind of holding the control panel up from coming out a little bit further. So just looking over this relay, everything seems to be connected the way it should be. That pin is supposed to be empty. The wire below it is supposed to go over to the other relay, which it does. The wire, I guess, to the right, that one should go to the switch. So if we follow that over, yep, it does go to the switch right there. So that is correct. The one here also goes to the relay. That is correct. And the red one goes down to the fuel solenoid on the propane. So this is actually wired correctly. So let's double check the switch. All right, and the switch, I guess the way we're looking at it is kind of upside down from the wiring diagram, but these two wires, they are supposed to be doubled up. One appears to go to the low oil pressure switch, and the other one goes to the relay. So this is the one we were just following over to that other relay, the one with the missing cap. And the brown wire, let's make sure that goes to the low oil pressure. And yeah, that is the wire that goes to low oil pressure switch. So that is good. And there's two wires coming out of this one. According to the diagram, one of them goes to the low oil light, which it does, and the other one goes over to that bridge rectifier. So this is a ground. So that appears correct. The diagram does show this pin open. And then the one below it has one wire, which is supposed to be a ground wire, and that runs over to the starter solenoid that we replaced earlier. And yeah, that one appears correct. The one here on the left, I guess furthest away from you, that is supposed to be open. And that just leaves this one right here. So one of the wires actually goes through a fuse, and that's actually picking up the power from the starter solenoid on the post that's always positive. And the other lead should run over to the relay. So let's double check that. And yeah, the blue wire goes over to the relay, the one that's not missing the cap. And the blue one, yep, comes right over to the fuse. So far, the wiring is checking out. And let's have a look at this one. So according to the diagram, there is supposed to be a jumper here between these two terminals, so that appears correct. We then have a wire coming out, which is this one. And that one, let's see, appears to go over to the other relay, which it does. So that is correct. And then if we look at the other side of the relay, there are two wires here. One of them should be the output of the bridge rectifier, which is a blue wire, so that appears correct. And the other one should run, I believe, to the other relay, although it actually comes over to the switch. So is that correct? Yeah, that is correct. So those wires, the blue ones at least, are good. And on the other side, looks like we have a yellow and a red. So one of these wires should come over to the low oil light, which it does. And the other one, I believe, is the output, yeah, on the full bridge rectifier, which you really can't see, but that is correct. So yeah, wiring's looking pretty good. We only have two more wires to double check. And the last two wires here, they should be connected to leg 1 and leg 2. So I can tell blue wire is correct. That runs over to the circuit breaker, so that is one of the legs. And the other wire actually should be connected over here. And it's not. Instead, it runs over to that splice that doesn't look factory. So yeah, that is not correct. Technically, it may not be an issue. I guess it depends on, what this is doing. If this is the coil that energizes, or sorry, if that's the coil that energizes this relay, technically it would run on 120 like this. And if you move the wire over, it would run on 240. So why did someone do that? I'm not sure. So I was going to start just by replacing this relay with the one I have right here. This is compatible, the right voltage, plenty of amps as far as the rating goes. The issue is we only have a terminal 87 on this one, and we actually need 87A, which is normally closed when it's not energized. So this relay we can't use. I'm actually going to have to make a trip to the auto parts store and find something that'll work in that one's place. So until then, let's just correct this wiring situation, and once we get the correct relay, we can finish this up. And that brings us to the next problem. Looks like a mud dauber made his nest in here. So this is the terminal we need to move that gray wire over to. We're actually going to replace the wire. So I'm just going to break this up. We'll blow it out, maybe use some contact cleaner and try to clean this up. And I think we should double check it just to make sure that we have a low resistance connection, because based on what I'm seeing, we likely don't. So I'm going to leave the blue one alone for now. Although I say that, and I see some strands poking out. So change of plan. Let's get them both removed. If the fasteners even turn. Yeah, surprisingly, turns quite well. Terminals actually don't look that bad. It's just the clamps that were a bit rusty. And they spun out just fine, so this might actually be okay. So I think what I'm going to do here is just strip back the wire a little bit. We'll add some ferrules. We'll double up these wires, both with the blue, and in this case, the red to the gray. So let's get the tape off. And I'm going to cut this gray wire back, and we'll reroute it to where it belongs. I also did a close-up of that relay just to make sure it's a 240 volt relay. And it is. So supplying it with 120 like it was, can't imagine it was working all that well. So we're going to clip the end off of this one and get some fresh wire. And we'll do the same for the others. Actually, that fits on there pretty good. Okay, those wires are secured. Okay, we got some solid connections here. So before we can get the breaker back in and test the resistance, we actually need to replace this gray wire. I don't like kind of what's going on right there with that butt connector. So we're going to take it off the terminal where it connected over to the rectifier. We'll pull it out here and just run a new wire over. And you can see this wire, it originally was white, and I would say that looks like a 12 gauge wire. So I'm going to replace it with this one. It is actually 10 gauge, probably overkill. But I'd rather use that than one that's too small. So that'll go there. And this cable, we can leave it a bit long. It's not going to hurt anything. So I was just getting ready to test the breaker, and I was going to do it through the 240 output. And notice something. Usually on the 240, you have the ground, opposite that, the neutral, leg 1, leg 2. So the ground wire should be furthest to your left, and the neutral furthest to the right. But if we flip this over, what we actually have is, yes, the ground furthest to your left, but furthest to your right, we have a live wire. And the neutral is actually on where one of the legs should be. And that furthest one is a live wire. So that is correct. But that and that, they are reversed. So like that, this 240 is not going to work right, because if you plugged in a 240 load, instead of neutral, you're getting one of the legs, and instead of one of the legs, you're getting neutral. So between these two, you would get 120 volts. Between these two, you're supposed to get 120 volts, but you'd actually get 240. And between what's supposed to be leg 1 and leg 2, you should get 240, but in this case, we'd get 120. So yeah, someone definitely was doing something in here they shouldn't have been. So I'm going to backtrack a bit. We'll correct the wiring here. And I guess technically we can test the circuit breaker like it is, just knowing that things are wrong. So from the front side, we can test from neutral, which is one of the legs on the front side, to there, and from neutral to there. We want to see if the breaker is passing a low resistance connection. So let's do that real quick. So this should be a live wire, but as we saw in the back, that is neutral. And we'll probe to leg 1. We should see a low value, but we don't. 22 million ohms. And about the same on leg 2. So yeah, either the breaker's bad, maybe the stator's bad. The wiring's definitely bad. So I'm going to backtrack a bit. I'm actually going to disconnect the circuit breaker, at least on the input side, and we'll disconnect all the wires from the 240 out. This has to be redone correctly. And what I'm thinking is we'll test directly to the stator when all the wires are disconnected, make sure it's actually good and that the problem likely lies in this breaker. All right, so now that we have it out, let's just do a quick resistance check. Ideally, we should have a nice low connection. When we touch these probes together, it is 0.2, 0.1 ohms. That is a low resistance connection. That's kind of what we want to see here, at least something in the ballpark. So checking this leg, not too bad, 0.3 ohms. So that is a good connection. So that leg is good. We'll check the other side. And not so good. That is 570,000 ohms and climbing. So let's move the probes, try it again. And yeah, not much better. We're talking hundreds of thousands of ohms on this side of the breaker. So fortunately, that breaker's bad and needs to be replaced. So now that we have that circuit breaker removed, we have access to leg 1 and leg 2. And given things were wired improperly on the main outputs, it would be worthwhile to check this. So I've got a lead on the neutral wire, and we'll check one of the legs. Should be a low value around 0.3 or 0.4 ohms. And in this case, yeah, we're at 0.4, 0.3. So that actually is a good reading. And we'll check the other leg. We should see about the same. And yeah, 0.4. 0.3. So despite the wiring issues, I would say the stator, at least the main outputs, appear to be good. So let's get these two bolts out that hold this 240 in, because we can't actually access the screw holding these red wires in. And we need to flip the position of the red wires with the white and the gray to make the wiring correct. And last but not least, we need to get this relay disconnected. So I believe this yellow wire here on the left is wire 56. So, we have a few wires that are yellow, actually 2 of them. So I'm going to mark wire 56 with a dot or a line. The middle one should be 87A, 85 on the right, and the one running down here I believe is wire 30, which is red. So we'll get those disconnected. And this relay might actually work, but just given the fact that it's missing the cover, it's probably not going to work for too long. So we'll get that replaced at the same time as the circuit breaker. And we might as well test the relay while we have it, just to see if it was any good. So between terminals 56 and 50, that is the coil of wire. We should have resistance, which we do, 92 ohms in this case. And then this actually has 2 contacts here, normally closed, which is the one we were using, and normally open. So with the coil de-energized, we should have a connection between this one and number 30. So that's 87A and number 30, and we have absolutely nothing. And if we check 87, we should only have a connection there when the relay is energized. But in this case, we don't have a connection on either one. So yeah, this relay is actually bad. And this is the relay that actually kills the power for the fuel solenoid. So normally it should be closed and allowing the power through. And in this case, it's not. So the machine would have never started with this relay installed, likely because the contacts are just corroded. Although we could take it a step further and actually test the coil. I mean, technically we could probably clean the contact and get this to work again. But I think replacing it is the better way. But let's just see what happens here when we energize the coil. Yeah. And physically, you can see that opening. So the coil itself is good. And actually just moving it like that back and forth can actually bring back some sort of connection. So let's test again from pin 30 to 87. Look at that. It actually, I would say, is passable now at 5.3 ohms. So yeah, although technically not dead, you know, we don't have a cover. So let's get a new one. So just got back, made a few stops, and the first one was an automotive store. I picked up just a general purpose automotive relay with the same configuration, and most importantly, we have that spade for 87A, which is normally closed. So we have a good replacement for the one that we pulled out of the machine. You know, as far as the circuit breaker goes, didn't have a whole lot of luck. You know, I went to the big box store in town. They had plenty of circuit breakers, but nothing like this. So I called around to a bunch of electrical and HVAC supply houses, and no one had this in stock. So, you know, I was hoping, you know, if I just flipped it on and off a few times, maybe we'd get the contacts to clean up. But instead, they're both reading open circuit now. So yeah, we have an issue here. I'm not quite sure what I want to do yet. You know, I kind of hate ordering something like this, given that the machine is completely unproven. But let's give that one some thought, and while we do that, we'll get the new relay installed. And I'm going to move the relay, actually. I'm not sure where it was originally mounted in here, but there's not a lot of space. So instead, I'm going to run it down to where the battery is, and we'll remote mount it down there. So to do that, we do have to lengthen a few wires, which I've already done 2 of them. I actually replaced the yellow wires with this black, and there's plenty of length to run down to the battery. So that is all set. The red wire, which goes to the fuel solenoid, that one is long enough already, but we do have to replace the brown, which is pretty short. So we're going to put a red wire in its place. We'll run it down to the battery and get everything plugged in. And for this one, we're going to have to butt connect it. You know, I hate doing that, but this is also a specialty spade terminal, and it allows 2 taps. So, you know, if I replace this, then I won't be able to tap it like it is now. So instead, we'll just extend it. right, so now we're going to get this reconnected. So the yellow wires are now black, and the wire that had the 3 dots is that black wire right there. The other black wire, which used to be yellow, goes in the center on 87A. And on the side was the brown wire, which is now the red one. And the wire that has always been red runs over to the actual fuel solenoid. So that one goes on the bottom. So in a last-ditch effort, I'm trying to revive the circuit breaker just by flipping it on and off. And initially, we had nothing on either side, and we're making a bit of progress. On the far side, that's consistently testing well, or at least halfway decent, at around 10 ohms. And the other side, still getting nothing, at least when the switch is on, but if I move it a little bit in the off direction, we get a good connection. So we're getting close. I hate to sink money into a new breaker until we have the engine and the generator working. Right now it's an unknown. And this breaker has to work. Otherwise, the control panel won't have power, but more importantly, the fuel solenoid won't energize, and the engine won't start, or at least it won't stay running. Potentially that is why it ended up left overgrown in a garden. Someone was definitely messing around with the cutoff solenoid for the fuel, so maybe they were on the right track, but ultimately it's the other solenoid in the machine. And look at that. So the switch is fully up. And it's hard to get a good connection, but yeah, we are. About 3 ohms, so actually that's excellent, or at least a lot better than it was. And on the other side, we have about the same. So I'm not going to touch this. As it is right now, it'll work long enough to test with. And we'll also get some ferrules on the main wires coming out of the generator head, leg 1 and leg 2. And once we have the circuit breaker reconnected again, we can test through the outlet and make sure, the breaker is still functioning and that everything is as expected. Did I not tighten that? So while getting this breaker installed, I realized we had a problem over here. I was kind of worried about it. I ended up putting a 10 gauge neutral wire mixed in with a 12. And the way this one clamps down, it was only clamping down on the 10 gauge, and actually this one pulled out. So I'm going to swap this heavy gauge wire for actually a 12 gauge, and we'll match what's already in there. Okay, we're good. And let's see if the circuit breaker held. Kind of got moved around a lot during installation, so it might have jarred things. So leg 1, good reading, 0.5, 0.4. Let's try the other leg. And unfortunately, we're back to high resistance. So we're at 12,000, which isn't great. So let's play with this a little bit more until we get a low reading. All right, I'm going to take that for the win. We're at 4.6 and like 0.4. So yeah, not great, but good enough for testing. So although this wire was never supposed to be connected to anything, I'm actually kind of glad it was left there, because that was the whole trigger that led me to open up this control panel and just see what a mess it was. So there were a lot of issues in there. Most of them have been sorted with the exception of that circuit breaker, but I think it's at least good enough that we should be able to get power out of the receptacles. So we've got spark, we've got compression. Really, we need fuel. So we're going to look at that in a minute. But first, let's get the blower housing back in place. So we're going to reuse the filter, both the pre-filter and the main filter. They were actually pretty clean. All right, well, I don't hear any propane hissing out, and I don't smell any, so I think we're off to a good start. Just going to soak everything down and make sure we don't have any leaks. Given all the problems we've had so far, just getting to this point, wouldn't surprise me if we had leaks. And look, it is leaking from there and there. We also have a leak right there. And this one's actually sealing. So, yeah, not good. Let's see if the problems continue over here. Yep, and we're leaking over here too. So this whole thing is pretty much a big leak. So I think we're going to take this regulator setup off and we'll put a brand new one in its place. And the propane, it is shut off, but there is residual pressure in the line. And could we fix this leak? Potentially. But the fact that we have so many on this setup, I think we're better off just replacing it. And we're actually going to have to swap this piece out as well, because the propane lines I have a smaller flare than what's on here. Let's try this again. Looks pretty good on this side, no leaks. And same thing over here. So at least we know from the tank through the regulator to the generator is good. You know, this is going to be hard to test because there is a fuel solenoid. So there should be no propane advancing past that. But as far as I can tell, we are good. So let me get you set up a little bit better. You know, we'll crank the engine and hopefully this thing comes to life. All right, we get the propane turned on. I'm also using the breakout cord, so I've got 2 lights plugged in, 1 to each leg. So assuming we corrected all the wiring issues and the circuit breaker holds out, we should see both lights turn on. Now, if we didn't correct the issues, what we would have seen is 1 light would have blown out immediately at 240 volts. But like it is now, I don't think we're going to have that issue. You know, how will the engine run? Is it going to knock? Are we going to make power? I'm not sure. So, you know, let's try to start it. There is air in the line, so for sure it's going to be an extended crank. But hopefully it starts and runs well, and we see both those lights turn on. All right, so let's try to get this thing started. Now, my understanding of how this fuel solenoid works is that when I hit the start button, it is going to send 12 volts DC from the battery to the solenoid to open it up. Once the engine starts and the generator starts making power, the other solenoid should close, sending DC rectified power from the stator to the fuel solenoid to keep it open. Now, there could be a moment in between cranking and the engine getting up to speed where there's no power at all to that solenoid. So that could cause some difficulty. And when we go to shut it down, when we hit the stop button, that should trigger this relay down here to essentially open up the circuit to that solenoid, closing the valve and shutting the engine down. So, you know, hopefully that all works. You know, worst case, we can just close the valve on the tank. So let's crank the engine. Okay, so it was kind of a good test. I guess on the good side, the engine started without a whole lot of effort, sounded really good, and we did see that momentary blip when I stopped cranking the engine, and before that other relay closed, the fuel was running out. But it did close, and the engine got up to speed, both the lights turned on, and initially the voltage was good at about 128, maybe 130 volts, but it was ramping up quickly. So I kind of panicked, tried shutting it down, and it looked like it was going to work with the switch. There was a slight delay, but I got a little anxious and just turned off the valve because that voltage was getting too high. And I thought I saw a little smoke in this area or potentially dust. You know, it doesn't smell like an electrical issue, but there is a connector right down there that connects the stator up to this panel. And it looks like the voltage regulator might be there as well. So I'm guessing we have an issue here, but just to make sure, I'm going to start it one more time and see what it does. All right, so take 2, propane is back on. Well, this one, it's been fighting me pretty much every step of the way, but we're almost there. You know, the first time we started it, I think we witnessed the voltage regulator fail. I did see a little smoke coming out, and this time it just went right to full power at 158 volts on the 120 volt output. So likely that board has gone bad and needs to be replaced. So let's pull it out and have a look. And I think the better question here is, if this is bad, can I get a replacement? You know, when looking online at, the parts for this machine, the OEM circuit breaker discontinued, both those relays discontinued. Is this part discontinued? It might be. Oh boy. We got a mess down there. And that is the air intake for the stator, so probably need to clean that out. And the black and white wires, I think those are the output to the brushes. So nothing obvious as far as the board goes, although I say that. Nope, that varistor looks fine. The board in general looks pretty good. So, one of these components could be bad. I don't have a test procedure for this board. The good news is they are still available for about $40, so we can get a new one. The other thing I'm thinking is that, these terminals do have a lot of corrosion on them, and two of the terminals are the AC input that gets rectified to DC and sent to the brushes, but the other terminals, that's the sense winding. That's what monitors the output and tells the AVR how much power to output. So potentially, if the sense winding wasn't making a good connection, then that would cause the same issue we just saw. So I'm going to spend a minute, just clean up these spades. We'll plug it back in and see if we get anything different out of the machine. And as far as cleaning out that mess in there, not an easy task. Really, the only way to do it properly is to take the entire machine apart and lift it off the base. So yeah, not my first choice, but that intake actually extends to the other side. So we could have debris here as well. So I'm thinking what I'm going to do is stick the vacuum where we have access in that hole. I use compressed air to blow over anything that might be on this side to the other and hopefully clean up the majority of it. I've got the regulator plugged back in. It's installed loosely. The only difference is that the spades have been cleaned up, at least on the board. So let's get it restarted and see if anything changed. All right, propane is back on. Let's try it again. The voltage definitely improved. Still high at about 138 volts, but it did drop by 20 volts after we cleaned all those spade terminals on the board. So, there is a potentiometer on there. Likely we could fine tune it closer to 120, maybe 125 volts. But I'm thinking before we do that, the connectors on the wires also didn't look good. So I'm going to put on some new ones without any corrosion. We'll repeat the test and see if there's been any further correction. I guess the tough thing here is going to be just accessing the area. It is very tight, just to get in there and work, never mind record it. So I may or may not record it, but either way, we're going to replace those connectors, try it again, and hope for the best. All right, everything's been reconnected with new spade terminals. Let's try it again. So yeah, one step forward, two steps back. The voltage, it's right where it was back in the beginning at 158 volts. So there is something going on with that regulator. Potentially someone messed with that potentiometer and we could bring it back. But the fact that the voltage is so inconsistent tells me likely something's wrong on that board and it should be replaced. So that's what I'm going to do. I'm going to order up a new voltage regulator. They're only about 40 bucks. We'll also get a new circuit breaker. And at that point, all the known issues should be fixed. So while we wait for that new voltage regulator and the new circuit breaker, I do want to revisit this relay. We know it's bad. I was about to throw it away, but then I was thinking, it's not bad. Likely there is just corrosion on the contacts on the inside. So, this isn't meant to be serviced, but we could drill out these rivets and have a look inside. In worst case, we can't fix it and it ends up in the bin, but willing to bet we can fix it. And it is always good to have a spare. So what I'm going to do, actually, before drilling those rivets out, is just test it again and make sure that it is completely dead. So I'm hooking up this light to the battery. So the negative is connected. We'll do the same with the positive. Just want to make sure this light is good. And yeah, the light works fine. So now I'm going to connect positive to this post and positive to the output on the relay. And even if the relay is working, this should not light the light until the relay is energized. And when you energize the relay, essentially what it's doing is sending up a copper bus bar and making a connection between these 2 points. So it's pretty much the same as doing this externally with these leads. We'll just connect one here, which is the power, and the other lead to the output. And that's simply what a relay does, connects those 2 tabs. Now, the way that it does it is by energizing the plunger on the bottom. It's basically an electromagnet, and it pushes that bus bar up on the underside, making that connection. So if I add negative to here and then positive to the tab, we can energize that coil and just make sure we don't get any output from that light. And this last lead, I'm out of red, but it is a positive. And if we touch it to this tab, you can hear it clicking, but there's nothing from that light. And even when I touch the tab, a lot of times it's not even sending the current to the coil because that tab is just very corroded. So yeah, we do have some cleanup to do. So I'm thinking before we drill the rivets out, let's just get the wire wheel. We'll clean off all this corrosion, both on this post as well as the tab, and then we'll bring this over to the vise and drill that out and see if we can't get to the root of the issue. And actually, these two bolts here on the top hold these studs in. So I can't effectively clean the backside here. Or I should say I can clean it better, if we remove these studs, or essentially they're lugs. So we'll do that actually once we get it opened up. Let's see if we can get some of the corrosion off of here. So fairly easy to drill those rivets out. Let's bring this over to the bench and carefully open it up. So that little spring right there, that must be the negative that it picks up from this bracket. So we want to be careful of that, although looks like it's permanently attached. Set that spring aside. And we need to carefully pull this gasket up without destroying it. And we'll set that aside. And right here, that is the positive pickup, and that is the negative. So yeah, the only difference on the 4-post is they send this one through the top instead of down through the bottom to pick it up from the bracket. So this right here, this is just a little bit of WD-40 I used when drilling out the rivets. So let's dry that a bit. And underneath here should be the electromagnet, which is where things can get a little bit dicey because this and that are connected to the magnet. So if you just pull the magnet out, you're gonna rip those wires. And currently that part of the solenoid is working. So what we most likely have to do is push this tab through without breaking the wire. Might be easier said than done, just due to the corrosion. Let's see if the negative lead will lift out. And it's moving a little. Okay, that is loose. Okay, that one moved. And the other one did as well. And now the coil is loose. We just need to finish pulling this spade terminal out, hopefully without breaking it with a wire. All right, I think this will come out now. Good, and that is the plunger inside that gets pushed when this coil is energized. So that all looks to be in good shape. We have this cup here, which should lift out, and there's also the pin in the center with the bus bar. So yeah, I can tell already the bus bar might be okay. It actually looks really good. But you remember the pin or the post out here that had all the corrosion on it? Look at it on the underside. It is just pure green. So that is why this was not working. So all we need to do is remove this nut, get the post out. Easier said than done. And then clean up that surface. So the lug cleaned up pretty well. It'll definitely work like it is now. So let's get it back together, if we can, in one piece and see if it actually does work. So we're going to add that retaining nut back. And I actually loosened up the other side as well. So we'll just snug both of those down. And then we got to drop the bus bar in. And there, I think, was a spring underneath. It kind of fell out, so I didn't get to see where it was, but I think it goes like that. And that's going to push the bus bar down when you disengage the solenoid. So we might have to try this a few times to get that spring in. And it is in. And technically we could clean up that bus bar too, but it didn't look bad at all. So I'm going to leave good enough alone. Make sure everything works. And at this point, we could actually test it using a multimeter. You just push down and see that a connection is made. So actually, let's do that real quick and make sure it's clean enough to function. All right, so I got that set to test continuity. And the sound probably doesn't come through very well. So let me tilt this up so you can actually see the resistance as well. And we'll get one lead on each side. And initially there should be no connection, no continuity. But when I push the bus bar down, ideally we'd get a connection, but actually we're not. So yeah, maybe I need to clean that bus bar as well. So yeah, let me take a second, do that, and we'll try it again. So it definitely polished it up a little bit. And I ended up pulling the other lug out as well and just spent a second polishing that with the wire wheel. So in theory, well, there's no excuse for it to not work. And I believe that spring is in the right spot. So let's put the cup back in. And we'll do the same test. One lead on each post. And let's push the plunger down. Yeah, and there we go. So less than 1 ohm. Consistently. So this is repaired. Well, assuming we can get it the rest of the way back together. So the next thing we need to put back in is this coil. And at the same time, that spade terminal. All right, that looks pretty good. As far as I can tell, that wire is still intact. So the negative we need to get seated. Positive is seated. And even though that's crooked, I think that's how it was. Like the actual base plate is flat, it's just the spring. That is a little bit sideways, but that is not going to hurt anything. So at this point, we just need to get the plate on. And I think this is just an insulator. And we had the spring, but I think even before that, we had the gasket. which I think went like that. And then the spring and the cover. So let me look around. I'm not sure if I have any rivets of the right size. Potentially we could use a couple bolts to sandwich this together. So the fasteners I have, they are too big for these holes. So likely we're going to have to drill things out and or find a way to get the rivet gun in there. But I'm thinking until we do that, or at least something that'll help, would be holding this relay sandwich together. So I'm going to add a zip tie, one in each corner, and we'll close this up. And then we'll try to get a better fastener in the other corners. And if we succeed with that, we'll cut the zip ties out and do the same to the holes where the zip ties are right now. So we're all back together, and at the very least, the part is now serviceable, now that those rivets are out of there. And that is a good thing, because these relays usually don't fail. They just get a case of the green crusties, which is what we saw here. So now that it's all cleaned up, this should work. So we're going to connect battery positive to one post, and the positive lead running to the light bulb on the other. And we'll also connect the negative that runs over to the light, right to the battery. We also need to do the same for the bracket, since that's where the coil gets the negative. So we'll connect that up to battery negative. And then lastly, the trigger. So we're going to connect the last lead to battery positive. And if we fixed it, that light should turn on when we touch the positive to here. And there we go. Works perfect. So yeah, just a case of the green crusties. And now that that's cleaned off, relay works as it should. Well, it's a few days later, and we've got the parts we need to finish this up. We got a new 30 amp circuit breaker, and we also have a brand new voltage regulator. So let's start there. Let's get this installed. We'll get the engine started and see if it has control of the voltage. And although we can just install it and call it good, I am kind of concerned about all that debris we found in there. And although I cleaned it out the best I could, I don't think it's actually clean. And that is an issue, because the stator, it needs to cool by bringing air in through the vents on each side and then up into the stator. So if there's any blockage, then the stator isn't going to last that long. So I think we can remove this panel without a whole lot of effort. Just a couple screws here on the bottom, a few on the side, and I believe this will lift out of place, and then it's going to provide access directly into that duct so that we can clean it out properly. So now that we have that side panel removed, you can see there is still some wood chips in the unit that have to be cleaned out. But more importantly, the cooling for the stator, it has to draw air in through here and then up through this end cover, and the hot air exhausts right there. So the intake, although it's cleaner since we cleaned it out, if you look further in under the stator, it is plugged solid. So yeah, that stator, as it is right now, has no chance to cool. And if we actually put this under load for any period of time, likely the insulation would fail. So let's get the vacuum back in there, get that fully cleaned up, and then we can get the new regulator installed. Yeah, we might have a bigger problem here. This isn't mulch. These are actually roots that grew up through the bottom of the machine. So it's not just as simple as vacuuming this out. Might need to cut it out. And not as bad on this side, but it is plugged up. So let's get that cleaned out, see if we can get a through path to the other side. Yeah, I don't think we can avoid this. That's actually a root growing through the bottom, as far as I can tell. and we have some more roots over there on the right. So my concern is obviously cooling, but we could have some intrusion of the roots as well into the stator. And although, removing the bolts down here, I'm not too optimistic about, we do have some engine mounts higher up, and these look like they'll come off. So there's 4 in total. We just need to remove those, a wire, a hose, a couple wires on the other side, and we should be able to lift this up at least a few inches, maybe more, to get access to kind of the core of the problem. So we get the low oil sensor unplugged, as well as the fuel line. And we'll tuck these wires in, and we're going to have to pay attention when we lift this up. We don't want to pull or stretch any of these wires. And the other big thing we need to do is unplug this quick connect, which should be easy enough. Although it might be corroded. Yeah, a lot of corrosion in there. I'm going to have to clean that up. So the other side, we've got everything disconnected. But we do need to remove these leads here. I did disconnect the battery already. So technically we could probably pull these wires through, but then we'd also have to disconnect the starter solenoid. And I think it's just easier to get it detached on this side. We also need to disconnect the exhaust, and it's a flex pipe down below, so I'm hoping we can flex it far enough away, to lift the engine out. Potentially we might need to pull the plug to give us a bit of clearance. This is definitely a first. Never seen roots in a machine before. I had to break out the pruner. So we're getting there. We actually have a through passage now, closest to me. But your side, yeah, I think it's going to require a little bit more. All right, and we are through on your side as well. At least in one of the channels. There's actually a total of 4 channels on each side, and there is definitely a root in the worst place possible. It's kind of in between where I can get to it. So we're clear on this side. Pretty clear on this side. There is a little root ball going through, which we might leave. Far side. Not perfect. I think in general there are a couple roots right here. So it is clear on all channels by me and clear on 2 of the 3. Although none of them are obstructed anymore. Regulator installed, which should bring this thing back to good health. Alright, so we're lined up as far as the notes go. Now things look good, so let's drop it the rest of the way. And reconnect everything that we disconnected. Actually, you know what? On second thought, let's leave these screws out. We might need to adjust the voltage, so we'll test it first and then secure it. Well, we're getting pretty close. We still need to connect the ground wire, obviously get the sides on, reconnect the battery and the propane, and we should be ready to try this thing again to see if that regulator fixes the voltage problem. But I did want to put the brakes on for a second because the mulch being where it was, I can't explain. You know, initially I was thinking a critter potentially because we did find a nut up in the head. We found a little bit of mulch in the head. And when Jason actually brought this home, he said the inside of the unit had quite a bit of mulch in it that he cleaned out. But how did the mulch get in there? There is no way in. You know, I've looked thoroughly. There's no holes, no cracks. And when everything's together, there is a panel right here. There is not enough room for a mouse to get in, yet this was packed. So I'm thinking all this was not caused by a critter, but might have been caused by something else. Meaning this was in a garden, and sometimes people pay to have mulch blown into gardens. So I'm thinking someone pointed that machine at the generator and all those little bits of mulch just blew through the slots and filled everything up. So yeah, if you have a generator in your garden, you might want to think twice before paying a service to blow mulch into your garden. All right, let's give this a try. Hopefully that regulator solves the voltage issue. So we've got one light plugged in and turned on. We've also got the kilowatt. So let's crank the engine and hopefully this fixes the problem. And that did it. The new regulator has no issues at all controlling the voltage. We were on the high side of okay at 126 volts, and technically we could leave good enough alone, but since there is a potentiometer on there, I'm going to adjust it down just a bit. You know, I do like to be on the high side of 120, but 126 seems a little bit excessive. So that is the potentiometer right there. And typically, you want to turn it counterclockwise to bring the voltage down. On a Honda clone style AVR, a full turn will bring it down about 2 volts. But this is not a Honda clone AVR, so I'm going to start conservative and we'll just do a quarter turn counterclockwise and see what that gets us. Yeah, interesting. It was turned down all the way already, so we can't actually turn it a quarter turn counterclockwise. So I guess we could turn it a little bit clockwise just to see if the voltage goes up or down. But I have a feeling we're locked in on this machine with a minimum of 126 volts. So let's start it again now that we turned it a quarter turn clockwise and see if the voltage went up or down. All right, so place your bets. Did the voltage go up or down? I'm thinking it went up. Yeah, it went up. So I'm going to set that back to the minimum setting and we'll call it good enough. And I've set that AVR back to where it was. Let's just make sure that we're back to 126 volts. So I think it's safe to get this AVR secured. 126 volts isn't bad. Kind of interesting though, the potentiometer isn't centered. A little better. But this AVR2, I don't think does a great job maintaining voltage under load. So it might be that we have to set it a little high to compensate. And before we finish it up, let's get the oil changed. It's definitely earned it. For a while there, didn't think it was going to come back. Well, the good news is there's no glitter in the oil, so the engine's healthy, but the oil is definitely contaminated with a bit of water, likely due to condensation and just years sitting outside without an oil change. So let's put a new filter on, we'll fill it back up with some fresh synthetic, and then we'll finish it up. And let's see if we can do this without making a terrible mess. Wow, that filter. It's on there pretty tight. There we go. And I did pre-fill this filter a little bit more than halfway. If you do it anymore, I'm probably going to lose the oil while installing it. Yeah, I think we're there. Maybe a touch past full. But let's make sure. And yeah, we're like right there. So that is pretty much perfect. And that just leaves the circuit breaker. So this one's not in great shape, although it has been working good enough for testing. But initially, it was open circuit, and I don't trust it. It's definitely on its way out. So I tried to order up the exact same one. Unfortunately, all the identifying information was on this sticker, which is no longer present. So I went to the parts diagram, looked up the Briggs part number, and really just hoping to see if I could find the manufacturer's part number on a picture online, and came up empty. The OEM Briggs part also discontinued, although I was surprised to see that the OEM part was actually an AFCI and not just a traditional circuit breaker. So someone has replaced this at some point, and here we are again about to replace it. The only problem though, the one I got, not exactly the same form factor, so there's a chance it might not fit. And even worse, I went to just test it, and the breaker won't actually turn on. It's kind of set or stuck in the trip position. So yeah, brand new part. What does new mean? Never ever worked. So this is going to cost us about a week. And just for the record, this voltage regulator, the one that we replaced, the potentiometer was not turned counterclockwise all the way. So potentially it's good, although that still wouldn't explain why we had a 20 volt difference at one point during testing. So I'm going to hold on to this. Potentially it's still good. All right, so a few days later, I've got a new, to me, used breaker. The thing that attracted me to this was the price, but also it's exactly the right shape as the one we're replacing, whereas the new one that we tried, doesn't reset, and it's a different shape. So this one will be a better fit, and you can see the resistance is quite low, 0.04. Let's check the other side. Hopefully we see something similar. And no, it's a little higher over here. If I can get the lead to stay on. Let's make sure. Oh, you know what? It's just the connection to the lead to the breaker. So we're actually at 0.8 on this side. So yeah, this breaker, I think it's way better than obviously the new one and the one that's in the machine right now. So let's get it installed and put that machine to the test. Well, I think we're about as ready as we're going to get on this one. So the big question is, will this machine pull its rated load of 7,000 watts? Of that, I am not sure, but we are about to find out. So the plan is to get the engine started. While it's warming up, we'll double check the output using the kilowatt to measure the voltage and the frequency. We'll use the amp probe to measure the total harmonic distortion in the oscilloscope to see what the waveform looks like. Now this one, despite the fact it looks like a standby, I can't hardwire it into the house, or in this case, into kind of the full load center. So we have instead the load bank plugged directly in, which is capable of 10,000 watts, which is more than adequate to test this machine. So, assuming everything checks out without a load, we'll put on a half load, we'll double check the outputs, and if everything looks good, we'll go for the max of 7,000 watts. And the plot thickens. So we were actually outputting 240 volts on the 120 volt output. And not all of them, actually just the bottom two appear to be at 240 volts. The top two, 120. So yeah, there is still a wiring issue in here that has to be corrected. So let me peel the covers back off. We'll locate and correct that problem. Yeah, this is kind of a mess. I thought I found all the issues, but clearly not. I did not pay enough attention to the 120 side, but this is wired completely wrong. If you look at it, the way it is wired is that the top and the bottom are different legs. That's why you see two wires here on the live side and two wires over here on the live side. And these are correctly going over to the circuit breakers from live. The odd thing is that if I follow the neutral, which is colored red, not the best choice, but likely that is factory. That is on the neutral side on this outlet. It's on the neutral side on this outlet. Then it connects over here to leg 1. That is absolutely incorrect. That should be over here on neutral. So yeah, I'm tempted to change wire colors, but just given how everything's cut here, I think this was the original color. We just have to move red into white. And this gray wire should be a live wire because that is coming over here to a circuit breaker. And it's actually feeding two breakers. And then those gray wires are coming over. And in the case of the top outlet, at least this one, it does go to where it should go. But in this case, it's neutral. And that's why we got 120. Between neutral and live, they're just backwards. And if we look at the other one, yeah, that's connected properly as well. It's just the mistake is over here. And the wire color's not great. So, I think I just followed the guy before me, putting red with red and white with gray. It kind of makes sense, but looking over here doesn't make sense at all. And on the bottom, we already know that this wire right here, the red one, should be neutral, but it's actually connected to leg 1. And if we follow the blue, I suspect that we're going to see that that's connected to leg 2. And yeah, it's hard to see, but that is the blue wire right there going into leg 2. So pretty easy mistake. I think all we need to do is flip these 2 wires and all of this should be good. I'll double check these connections, make sure they're actually tight. That one is a little suspect. So let's correct that issue and try this again. And now I think we're good. So yeah, easy mistake to make. Why would you put white on red and red to gray? It makes more sense the other way. But that was definitely not the right way. So now if we follow all the wires, forget about the diagram for a second. We have the ground coming in right here, and then it's jumpered over to there, which is correct. Then we have neutral coming in, which turns to red, and it goes to the neutral side, gets jumpered over to the neutral side. And nothing goes through a breaker on the neutral side. That's the way it should be. Then you have leg 1, leg 2. So leg 1 is the red wire coming in, changes to gray, comes over here to this breaker, and then is jumpered over to the other breaker. So the outputs are the gray wires, which are connected on the top of each of these 120s. So that is correct. And then we finally have the blue, which is a lot harder to see. But the blue comes from the breaker, goes over to there, then it jumpers over to this breaker, and then kind of piggybacks over to this breaker. So the outputs are the blue wires, one to there and one to there. So that should be perfect. And these terminals, they aren't loose. The screws are tight. That's just kind of how they are. So now I think we'll be good. So I'm going to get this back together. We'll try it again. All right, we're all back together. Let's try this again. Right now the kilowatt is plugged into one of the top outlets. So as soon as it started, we'll double check the voltage, and then we'll move it to a bottom outlet and make sure things continue to look good. So that one simple change was a pretty big mistake or oversight on my part, and definitely a wiring issue for sure. But now things are corrected. We're at 125 volts both on the top and the bottom outlets. Although I guess the one good thing to note is that the kilowatt, it's only rated at 120 volts, but it seemed to handle the 240 at least for a short time without issue. Anyway, without a load, THD isn't that bad. We're at about 6.6%. And the sine wave, not great, but fairly typical for a portable machine like this. So let's put on a load. Start with 2,000 watts. No issues, engine speed remains good at 61 hertz. 3,000 watts, 3,500 watts. No issues, engine speed's holding perfect. THD did jump though, We're at 17.2%, and the sine wave, not as jagged, but definitely not great. So let's give this a few minutes, and then we'll go for the max of 7,000 watts. Well, it's been a few minutes and no issues at all pulling a half load. The engine speed's actually quite good at 60.5 hertz. So let's take off these lighter loads. We'll put on a 2000. So now we're at 4,000 watts. 5,000. Engine speed's good. Let's try 6,000. Came down a little bit. We're at about 59.5. Let's try 7,000 watts. So yeah, I think we're at the limit. Engine speed's definitely lower at about 58.5 hertz. THD came up quite a bit. We're at 20.4%. And the sine wave, yeah, doesn't look great. So let's give this a few minutes, make sure things continue to run well. All right, it's been a few minutes, no issues at all pulling a full load. So the question is, do we go for more? Let's try 7,500, 8,000. Yeah, so the engine has plenty of power. It's hard to believe given where we started. So let's give things a few minutes to cool down, and then we'll shut it down. All right, guys, and that is pretty much a wrap. You know, this machine, going into it was a big unknown. Thankfully, it was free because, as we found out, it was a complete disaster. You know, the engine was stuck. We had mulch in places where it didn't belong. Voltage regulator was bad. Propane regulator was bad. Propane lines were bad. Circuit breaker was bad. And the wiring was just a disaster. So we got all those issues corrected. Thankfully, nothing terminal was wrong with the machine. And now it's back up and running 100% like it should. So I hope this video helps someone. Thanks for watching.